Okay, welcome to 6502 Emulator in Python Part 4 with Tokyo EdTech. That is me. In today's lesson, we are going to do some more code improvements. We're going to separate the CPU from the runner. And I think in this case, I'm going to call it the system because that's what runs the CPU, is you need a system around it. And then I'm going to implement something called flags. The CPU has these flags. They are either true or false, I mean on and off. And there are four that I want to take care of today. They're called carry, interrupt, overflow, and decimal. So carry is used when we're adding or subtracting. Interrupt is kind of a CPU thing where there's this, I don't know what you call it, like a special mode where the CPU is interrupted and something else takes over. There's overflow, which is when you go beyond a certain value. And then there's decimal mode, which is where it kind of tries to mimic decimal as opposed to hexadecimal. So I don't, be honest, don't know a lot about all of them, but I do know that they are flags and I think I know how to implement those. So let's go ahead and take a look. So here's what we have so far is we have our CPU, and if I run this, again, you're probably coming from the most recent video. If you haven't seen parts 1, 2, and 3, watch them. And if you recall, I was having some problems getting this to run, and it's only, I think, with the OBS running and recording. So let's go ahead and run that. So we have load the accumulator with A, which is 10. Anything else changed there? And then we loaded X with 1. I think we stored it and then loaded it and boom, boom, boom. Anyway, not the important part. So we know this is running. And what I want to do is I want to separate this CPU from the code that's running. And this will, again, help us create a system at some point. So what I'm going to do is I'm going to go ahead and just copy all of this stuff. I'm actually going to cut it, save. And then over in here, I made a program called system.py, and it's in the same folder as the CPU 6502py. I'm going to paste it. And then what I'm going to do is I'm going to do from CPU 6502 import asterisk. And what that does is it imports everything from that. Okay, so I'm going to go ahead and run this, and what I should see is exactly the same thing. Okay, so when I see import A, I think it stores it, then loads X with 1, and then it maybe loads A, X1. I'm not quite 100% sure. I forget exactly what that does. Watch the previous video, but I'm pretty confident that it's doing exactly what I wanted it to do. I didn't see any change in the output. I'm going to call that a win. So let's go ahead and go back to our 6502 CPU, and we're going to implement flags. Okay, so flags are similar to the accumulator X and Y registers and the PC register, except they are just 1 bit. And when something's 1 bit, that means it's a Boolean, it is true, or it is false. So let me go back here and just make sure I got this right. We've got C, interrupt, carry, interrupt, overflow, and decimal. So let's go back. And so what I'm going to do is I'm going to do self dot carry, and we're going to set it to false at the beginning. Okay, and it should be capital false. We're going to do self dot, let's go back again, just so I don't mess it up. Interrupt, so interrupt equals false. Self dot, what was it, overflow equals false. And self dot decimal equals false. Now the rule 6502, I don't know if you're guaranteed that's going to be the way it's set up, but let's take a look here one more time. Carry, interrupt, overflow, decimal. Okay, I think I'm pretty happy with that. So let's go take a look at our command. So we've created these flags. They are on or off. That's what a flag means. It's either true or false, on or off, depending on how you want to view it. So if we go back to here, we have some commands that are related to that. So we have clear carry and set carry. We have clear interrupt and set interrupt. We have clear overflow. Notice we don't have set overflow. That happens in a separate process. We have clear decimal and we have set decimal, and we have some hex values here. So you see here, these instructions are implied mode. That's important. We need to know that. They have a length of 1 byte. That's important. We already know that. They require 2 machine cycles. So far, we haven't worried about the machine cycle thing. We could implement that later, but for now, let's just keep going the way we are. I'll probably regret that, but for now, let's just go ahead. So I'm going to go ahead and just to make my life easier, I'm going to go ahead and copy this. I'm going to pop it over here into my code. And what I'm just going to go ahead and add this down here. Oops. Okay, so I'm going to go ahead and so I'm going to do 0x38. And actually, why don't I make my life easy and just copy, delete what I don't need here. These are implied, so they're 1 byte. So we have 1, 2, 3, 4, 5, 6, 7. So we've got 7 of these. So I'm going to go ahead and copy. That's 1, 2, 3, 4, 5, 6, and 7. So I'm going to do 0x18, which is CLC. We've got 0x38, which is .sec. We've got 0x58, which is CLI. Again, for now, you don't really need to understand what these all do. We have SEI, 0x78. Just set the interrupt. So clear interrupt, set interrupt. We've got clear overflow, which is CLV, B8. And we don't have set overflow. We have clear decimal, which is D8. CLD. And we have F8, which is set decimal. F8, which is S set decimal. Okay, so I'm going to go ahead and just kind of delete those because we have them here. I'm going to save it. Now, if I try to run this, you'll see nothing happens because we got to run it from the system now. Okay, so we'll see CPU object has no attribute CLC. So that means now I got to go down here and make my commands. So I'm going to go ahead and do, what was it? It was CLC, SEC. One more time. Let's go check. SEC, CLI, SEI, CLI, SEI. It's a little annoying rolling through. CLV, CLD, CLV, CLD, and SE set decimal. Okay. So I'm going to go ahead and do def CLC self mode, and this one doesn't really matter the mode because it's implied. So all I do is self dot carry equals false. Okay. And what I'm going to do is I'm going to go ahead and just copy that. Try not to make any mistakes. CLI, and this should be interrupt. CLV is clear overflow. Again, it's not super important at this point what they do. And then we'll go ahead and do clear decimal. And then let's go ahead and do set def SEC self comma mode. Oops. Self dot carry equals true. And for the setters, I'm going to go ahead and just copy and paste. be SEI, which is set interrupt, self.interrupt. Now I could call it self.I, self.v, etc. Yeah, you can do it however you like it. I just like to print it all out because I think it's easier to know what we're doing. CD, and this should be decimal. All right, I think we're good. Let's go ahead and try and run this. Compiled at least. Okay, we compiled. That's a good sign. Let's go ahead and run that. Okay, so it's still running. That's a good sign. Everything's still working. So what I'm going to do, now that I have these registers, I'm going to go ahead and add them here. So I'm going to do print f quote, and the first one was back to here, carry CIVD. All right. There's a couple other ones we could deal with right now, but we'll do it like this. CIVD. And we're going to do print. How do I do that? That's the best way to do this. Well, let's try it. Let's see what happens. So it should be F. I should have it. Let's just make our lives easier, and we'll do it this way. Oops. Carry. And it's going to be self.carry. Copy. One more time, it was carry, interrupt, overflow, decimal. Carry, interrupt. It's going to be overflow. And this will be decimal. Let's go ahead and run it again. Okay, shouldn't see anything. We're going to run it here in the system. So we see false, 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 false. Okay, so it basically stays the same. So what we could do, and I noticed also when I was watching the video, this should be DBG, not DGB. Again, if you're watching at home, it's a lot easier, trust me. All right, so let's go ahead and do test flags. So what we'll do is we'll do CPU.push, and we'll do SEC, set carry, and then we'll do debug so we can see that the result of that works. Okay, and I'm going to go ahead and copy this. There are 4 flags. So it's SEC, SEI, and SED. Oh, we only have 3, sorry. SEC, what was it? SEC, SEI, and SED. SED, and SEC was what? Just do a quick check. So SEC 38, 78, F8. 38, 78, F8. So 38, 78, and I think it was F8. But I will check that because I do forget things. F8, I do forget things a lot. All right, so save. So let's go ahead and run that. Okay, so we have set carry is true. We've got set interrupt is true. And we've got set decimal is true. Again, there is no set overflow. Now, if we wanted to, we can go ahead and continue testing this and go down and, we could check the, clear decimal. But I think you have the idea. Okay, so hopefully that'll work. Again, we should have proper testing harness, but we do not. But you get what you pay for. So let's take a look real quick. Coding concepts. So we have separated the CPU code from the runner, or from the system code. So that's just to kind of make things a little bit easier. Again, later what we want to do to add to the system is we want to add some kind of video RAM and some sort of keyboard type thing, and maybe a GUI or something like that. That's for like way down the road. But what we want to do is we want to focus on how the CPU itself functions, and we'll see how close we can get to a real 6502 without driving ourselves too crazy. So we added 4 flags. We added carry, interrupt, overflow, and decimal, and we'll need those later when we start coding a few different things. We added the commands. What did we add? We added clear carry, which sets it back to false, set carry, which sets it to true, clear interrupt, which sets it to false, set interrupt sets it to true, clear overflow, which is false. Notice we don't have set overflow. And then we have clear decimal and set decimal, decimal mode. So yeah, I think that's what we did. See, I was kind of going through the code there, and I realized I was still on the coding concept screen, but you know what? I think you saw it earlier. So thanks for watching, and keep on coding.